Now we're ready to talk about the derivative of the natural logarithm function. And keep in mind the natural logarithm function. It's a logarithm with a base of e. So, going back to the definition of the derivative, we'll have the limit as h goes to 0 of log x plus h minus log x over h. Well, in the numerator, we're subtracting logarithms. And you may remember from the law of logarithms, when you subtract logarithms, what that means is that's really the log of a quotient. So x plus h divided by x. Or in other words, limit as h goes to 0 of 1 over h log, and then I can also write that as 1 plus h over x. And so notice that this factor out in front, this I can make a power. But what I'd like to do is have something that's going to actually turn into the limit for e. So I want something that's going to be the reciprocal of this. So what I'm going to do on the outside, I'm just going to multiply by an x and a 1 over x. So I'm going to have a 1 over x and an x over h times log 1 plus h over x. At this point, I'm going to make a change. I'm going to say that u equals x over h. And notice that the limit as h is going to 0 is the same as the limit as u is going to infinity. So this is going to be a limit as u goes to infinity of 1 over x times u times log of 1 plus 1 over u. This is going to be a limit as u goes to infinity of 1 over x. Now I'm going to bring that u up to be a power. 1 over x times the logarithm of 1 plus 1 over u to the power of u. Well, now, of course, the 1 over x is just going to stay 1 over x, so I'm going to factor that out, and I'm going to bring the limit inside the logarithm. So we have a limit as u goes to infinity of 1 plus 1 over u to the power of u. Now this limit, you may recognize, that is the definition of e. So what we have is 1 over x times the log of e. And of course, the natural log has a base of e, so log of e is 1. And so this whole thing just equals 1 over x. The derivative of the natural log of x is 1 over x.